So eventually we're gonna, you know what? I guess we'll talk about this later. I probably should have put this question first. So go to example 2. Yeah, because we're gonna derive something. You'll see right now. All right. So what's up? Oh. Can you give her this one? All right. So in example 2, guys. So it says here you can use linear combination property to solve certain trigonometric equations algebraically. Chav, what is this linear combination property? That's what we did yesterday or 2 days ago. Yes, Monday. Remember that on Monday, we said that we could transfer something like little a cosine some angle plus little b sine some angle into a capital A cosine some angle with a phase displacement. Of course, the catch is that you have to have cosine and sine have the same frequency, which you guys already know that. Same. It has to be the same frequency or same. If you have a 2 theta there, then that has to be 2 theta, whatever it may be. So yeah. So we can turn a linear combination of cosine and sine into a single cosine with a phase displacement. Do you guys remember that? And then we said, why would we want to do that? Because sometimes it's easier to analyze one signal than 2 signals. So that's just the whole point. This also transcends to everything, guys. The music, when you hear a tone, this could be a specific tone. This could be another tone. If as long as it's the same frequency, you can make that same sound with one cosine. With one, okay, I'll stop. For those of you that love music, you can go into it deeper, go to YouTube and see some music theory and all that good stuff. All right, so here we go, guys. So I'm focusing on this. Notice that it says that I want to verify this algebraically. Yes, I know that we can do this really fast with a calculator. With technology, we can just put this on y1, put this on y2, and see where they intersect. But let's do it algebraically. So how we're going to do that is I'm going to turn this into a single cosine with a phase displacement. So let's see, what am I going to do? So this negative 2 in the front, I'm going to do my hack. This negative 2 in the front is like a x. This 3 in the front of that sign is like a y. Do you guys remember that? So negative 2 comma 3. So here I am. I'm exaggerating. Negative 2 comma 3. Negative 2 comma 3. And you connect it to that like that. Here's my reference triangle. This angle here, that's the angle that I'm looking for. That's angle D. I guess. And then this angle here, that's theta R. Negative 2 and 3. And then this hypotenuse of this reference triangle, that's your A. Any questions right now? Not bad, right? All right, here we go. Amplitude equals, and I'm just going right to it, square root. All I'm doing is Pythagorean theorem, guys. Negative 2 squared plus 3 squared. All right, here we go. Negative 2 squared is 4. 3 squared is 9. And I had the square root of 13. Are we okay with that statement there, guys? Okay. So here we go. I already got my amplitude. I need now my phase displacement, the angle D. So to do that, I'm going to go angle D equals, I guess let's do it in pieces. So let's find that theta R first. Theta R equals arctan of 3 over 2. So I take my calculator. I'm going to go arctan of 3 over 2. I am in radian mode, 0.98279. 0.98279. All right. Angle D equals, I take pi, and because I'm in quadrant 2, I'm going to subtract my theta R. So pi minus 0.98279 equals, and let's see what I get from there. Pi minus, and I just scroll up, enter, 2.158798. 2.158. I already forgot it. You guys got it? Okay, 879. Need more digits. 893, like that. Okay, yeah, the more digits you can write, the better, guys. Are we still okay? All right, so why did we do all that for? So we just converted that. So now that is going to equal, so what am I going to get now? So new equation, and it's not new because it's really the same. So new equation is square root of 13 cosine, open parenthesis, x minus 2.158799893, close it. I'm going to equal that to 2. Chop, how does that help us? Sorry, we got an airplane coming. Okay. How does that help us? Well, now, guys, we can just solve for x the way we've always done it. So look, now how do I get, what am I trying to do now? Solve for x. So what do I do first? Get rid of that square root of 13? So I got to do what? Divide. So I have now my new equation is cosine x minus 2.15879, close parenthesis, equals 2 over square root of 13. And I'm trying to solve for x. What's my next move? What's my next move, guys? Our cosine. So I'm going to have x minus, I'll put a semicolon to indicate new line, 2.15879 equals plus minus arc cosine of 2 over square root of 13 plus 2 pi n. Do you guys remember when we used to do that all the time? And then my last move, Chop, why'd you put plus minus this time? Because 2 over square root of 13 is not a perfect coordinate like square root of 3 over 2 or a half or square root of 2 over 2. So since I don't know what this is, I just put plus minus in the front to take care of both of them. How do I get x by itself? Just move the... Not everyone at the same time. Yeah, just move the 2.15879 to the right. How do you move it? Chop, how do you move it? Just put it in the front. 2.15879 plus minus arc cosine of 2 over square root of 13 plus 2 pi n. Here are my two equations. Subscript x1 equals... So I'm going to write, what am I going to write? I'm going to take my calculator. I'm going to scroll up to this. And I'm going to go that number plus arc cosine of 2 divided by square root of 13. I don't see any issues. I think I did that okay. So 2 plus that. I push enter, and there's one answer. That looks like pi, actually. 3.1415. Yeah, that looks like pi. 3.14159 plus 2 pi n. You can put pi if you want because it looks like it is pi. Let's check if it is. I'm pretty sure there's issues going on because of rounding, because of all this, but let's see. Let's see how close it is to pi. It's pi. It's pi. That 4 there, that 3 should be a 4, but there's rounding going on because, see, that 3, it only went to there, but that number, this 2.158799893, it goes on forever. But it's pi. We verified it right here. So if you want to put pi in there, you can. That's pi. All right, the next one. Instead of adding 2 pi, instead of adding arc cosine, I'm going to subtract because I haven't done the minus one yet. So I just scroll up, I push enter, and I change the plus to a minus. And I push enter on that, and I got 1.176, which I'm sure will reduce to something with a pi in it, but 1.176. 1.17600. So I'm going to leave it like that then. 1.1760 plus 2 pi n. Are we still okay, guys? We're not even done officially. Well, we're about to. But all right, here are my answers. So answers are... So we got to get all the answers between negative 2 pi and 2 pi. So x equals... Here's one answer, 3.1415. So one answer is pi. Another answer is this guy, 1.1760, which I'm sure is pi over something. And then another answer, if I subtract 2 pi, so I can't add 2 pi anymore because then I'll be outside this domain. See, I'll be outside that bigger one, 2 pi. But if I subtract 2 pi, pi minus 2 pi, negative pi. So negative pi is one answer. And then that 1.176 minus 2 pi, let's see what that is. This guy, minus 2 pi. And another answer is negative 5.107. Shop, is that between negative 2 pi and 2 pi? Yes, it is. Negative 5.10. I forgot. 10718. 10718. 10718. And there it is. These are my answers. I would say verify. You guys haven't been doing a good job of verifying. And I know that because I just graded your activities. I'll pass them back to you guys right now. And some of the errors that you guys are making, not a lot, but the ones that you are making, you're just not verifying. So, Chop, how do you verify that? You could type in your new equation, but to get the best, type in your old stuff. Type in this. Negative 2 cosine x plus 3 sine x. So negative 2 cosine x, close it, plus 3 sine x. And then what am I going to do on y2? I'm just going to type in the another one. It equals 2, see? So I'm going to put 2. And I'm going to click window. And you're only checking between negative 2 pi and 2 pi. So I'm going to go negative 2 pi right here, negative 2 pi. And on the next one, I put 2 pi, 2 pi. And you only care about where you hit negative 3. But, you know, we do have a magnitude. What's your magnitude? What's the amplitude of the wave? Square root of 13. So what's the square root of 16? 4. So go negative 4 to 4 if you want to see it all. Negative 4 to 4. And then check it out. Graph. So there's my wave. And look, those answers, 1, 2, 3, 4. Those 4 answers better be the answers that I got. So let's see. Second, calculate number 5. Answer twice. Boom, boom. When it says guess, that means which one do you want? Let's try the furthest one. This negative 5 point something. Push enter. And negative 5.10718. Do I have that as an answer? Yeah, there it is. It's that one. The other one better be negative pi. This one right here better be negative 3.1415. How many digits of pi do you guys know? That's it? Oh. Okay, intersect, enter, and then hover over this one. And I believe that should be negative pi. Negative 3.141593. I think it should be 4, right? What's the actual pi? 3.1415926. Okay, so there's some rounding going on. It's fine, not a big deal, but it's correct. There's just some rounding going on with the calculator. But there it is, guys, and we did it. We did it. I bet you the others will match. Second, calculate number 5, intersect, enter, and let's see, which one's more exciting? The pi one? No, we already know that one. Let's just do this one, the 1 point whatever. 1.17600. There it is. We got it. Cool or not cool, guys? How do you guys feel? Okay. Do you feel okay? Do you have good energy? All right. We're going to need your A game for this. I'm going to tell you guys this. Relax. All right. And I'm not talking smack. Look, I'm being recorded right now, so I'm not talking smack. I can just give you the formula, and I can just say, just use the formula. But guys, I want you to understand where everything is coming from. This formula does not come from just anywhere. Chav, what formula are you talking about? I'm talking about this formula. So I'll go ahead and write it. We want to derive the formula for, and sorry that my handwriting is so bad, cosine A minus B. And I'll give it to you. I'll also give it to you in the next page. It's right here. Cosine A minus B, cosine A cosine B plus sine A sine B. So in the end, all I want you guys to be able to, I want you to be able to know how to use this formula. Cosine A cosine B plus sine A sine B. That's the formula. That's what we're going to derive. We're going to derive that. And it's right here. Cosine A cosine B plus sine A sine B. But guys, like what, I don't know, to me, this is just me, everyone's different. Like, don't you guys want to know, like, where did this come from? Who created that? Like, why does it work? Don't you guys want to know that? So that's what we're about to do right now. Do you have to know how to do it? No. I want you guys to follow along. Now, I am recording, so if you think you focus better by not writing any of this down and then write it down the second time around, do that. Just focus on understanding the logic. Cool? All right. So I'm going to start by drawing the first quadrant of the unit circle. And like I said, if you feel that you focus better by just viewing this and seeing if you understand the logic, then do that. Here is my unit circle. Just the first quadrant. I exaggerated it. I'm going to use different colors for different angles. I'm going to use red for angle A. So I'm going to say angle A. So here's the segment. And I'm going to say this angle here is angle A. So that means this coordinate is, giant parenthesis, the x coordinate is cosine A, and the y coordinate is sine A. I haven't done anything crazy. Are we still okay? Okay. And don't worry, I see you guys writing, so I'll let you guys catch up. In blue, I'm going to say that this angle here is angle B. So that means the x-coordinate on this is cosine B, and the y-coordinate is sine B. If you want to put a parentheses around your argument, that's fine. I just think it looks cleaner this way for now. Are we still okay? Okay. Now, let's make a note. The difference between angle A and angle B, this guy right here in purple, that is angle A minus angle B. Yeah, if you take angle A and you subtract angle B, you get that difference there between the red and the blue. Does that make sense to you guys? Okay. Nothing crazy, right? Okay. So what I want, so how are we going to derive this? Let's see. So what I want to find the distance between this coordinate at cosine A sine A and this coordinate at cosine B sine B. So let me go ahead and connect those two dots with a straight edge or a straight line here. I want to find that distance. Any 2 points, the distance between those 2 points, you could use the distance formula, which is just the brother or the sister of the Pythagorean theorem. So that means I can draw a reference triangle in here, a right triangle. I can do this. There's my right triangle. Do you guys see that? Where this distance here, we're going to call that the horizontal displacement. Horizontal displacement equals. And then I'm going to call this distance, this vertical distance here, I'm going to call that vertical displacement. Are we okay? And I'm just going to call this distance, I'm just going to call that D for distance. The hypotenuse. Have I confused anyone? Okay. So here's all I'm doing. How would I find the horizontal displacement? How would I find that distance with the values that I have? How do I find this guy? This distance right here. Well, if I want the horizontal displacement, don't I just take the x value of the blue dot and subtract the x value of the red dot? You guys agree? Or no? I just want the horizontal displacement, this distance right here. How do I do that? The x value of the blue dot, and I subtract the x value of the red dot. Horizontal displacement, cosine B minus cosine A, whatever that is. Are we okay with that statement? All right, what about the vertical displacement? I want a positive number, so how do I find this distance? You just take I want the y value of the red dot, and I subtract the y value of the blue dot. So how do I do that? There you go. Sine A minus sine B. Are we still okay, guys? Now, because I have a right triangle and I want to find the distance there, I can just use Pythagorean theorem. A squared plus b squared equals c squared, or in this case, a squared plus b squared equals d squared if I call the hypotenuse d. Do you guys see that, guys? So I can go and I can write it like this. I can say d squared equals the difference between the horizontal displacement. So I'm going to put a parenthesis and I'm going to write cosine b minus cosine A, close it, squared, plus, open parenthesis, my vertical displacement, which is sine A minus sine B, close it, squared. I just did Pythagorean theorem. That's all I'm doing. Pythagorean theorem. Does that make sense to you guys? All right, so now just comes algebra. All I'm doing is expanding this, guys. That's all I'm doing. What is cosine B times cosine B? Not everyone at the same time. Yeah, say cosine squared and then say B. Because you say cosine B squared, then the B squared, right? So say cosine squared B. Are we okay with that? And then when you multiply cosine B times cosine A, that's cosine B cosine A, but say cosine A first because A comes before B in the alphabet. So it's cosine A cosine B, but then you're going to have another one. So you're going to have two of them. So minus 2 cosine A cosine B. And then what's cosine A times cosine A? Oh, man. Do you guys know what I'm doing? No? Okay. Let's stop. Let's slow down. Guys, all I'm doing is squaring this right here. So where can I write it? Look, all I'm doing is this. Cosine B minus cosine A times cosine B minus cosine A. So all I'm doing is cosine B times cosine B, cosine squared B. Cosine B times cosine A minus cosine A cosine B. Cosine A times cosine B, look, that's another one. Minus cosine A cosine B. And then cosine A times cosine A, or negative times a negative, plus cosine squared A. See, that's all I'm doing. So notice these two right here, they're the same, so that I get two of them. So that's what this is down here. So cosine squared B is that guy, see? Minus 2 cosine A cosine B, well, there's two of them right here. So that's two of them. And then cosine squared A, so plus cosine squared A. Do you guys see what we're doing now? Okay. Yeah, it's the algebra that's going to trip you guys up, guys. All right. Plus, that plus is this plus. Sine A times sine A. Sine squared A. Bless you squared. Bless you cubed. Bless you fourth power. Bless you fifth power. Okay. Sine A times sine B. Negative sine A sine B, but how many am I going to have? So minus 2 sine A sine B, and then negative sine B times negative sine B. Yep, oh, and B, sine squared B. I think we're good. I don't see any issues. Yeah, I think we're good, guys. All right, let's see what we have. I'm gonna rewrite some of this. So I see, what do I see? So I want to keep the same angles together because of the properties. So you see that cosine squared B and this sine squared B? Cosine squared B plus sine squared B, that's equal to what? 1. So there's that 1. And then let me change the colors to signify this one here. Look, this one right there. Cosine squared A plus sine squared A. That's another, what's that? Another one. Yeah, who's that? DJ Khaled? Another one. So then what's 1 plus 1? So write 2, and then these don't add up because that's cosine A cosine B. That's sine A sine B. So minus 2 cosine A cosine B minus 2 sine A sine B. All right, and then we retire that and we leave that alone for now. Leave alone for now. Are we okay? No one's mind is hurting right now, right? We're okay? All right, check this out. Look what we're going to do now. We got plenty of open space yet. Let's exaggerate quadrant 1 again. I'm going to write it right here this time. So I'm going to take up like 1/3 of that page here. And then did I do it in red? No, I did it in black. And here's what I'm doing. You know what? Let me give you a heads up in advance. Here's what I'm doing, guys. I'm taking this. You see this angle A minus B? I'm just lowering it like that, where the blue line is going to hover on the x-axis, and the red line is going to be like that. So I'll try to color code the same thing. I'm just sliding it down like that. So here it is, and here it is. Here's my blue line, and the blue line now is down here in that same image. And here, let's see where I use red. So I'm going to say red. So I'm just translating, right? Sorry, guys. Let me put this in volume. Let me turn off the volume. Silent. Okay. So here it is. So that's still the red dot. That's still the blue dot. But now this here, I'm just going to call this A minus B. And it's supposed to be the same image as before. So I'm going to put translating or well, that's fine right there. You still okay? Since this is a unit circle, this coordinate down here, that's just 1, 0. And this coordinate up here, I mean, I guess you could call it cosine A sine. Well, no, because that's A. I'm going to call it now. This is the angle that I have, A minus B. That's this angle here, A minus B. Like I said, I just translated. I just shifted it down degree-wise. And so that coordinate now is going to be cosine A minus B, comma, sine A minus B. Are we still okay, guys? This distance is still the same one as this one. I just didn't, I kind of drew, no, I didn't draw it as good. That's fine. That distance is still the same. This right triangle is still the same. This is still D. And I'm still doing the same thing. This is still my horizontal displacement. Horizontal displacement. And this is still my vertical displacement. Vertical displacement. We're almost there, guys. We're almost there. All right. Here we go. You guys ready? My horizontal displacement. Let me zoom out. So, new. Okay. Here we go. My horizontal displacement. For this one, I'm doing rightmost point, rightmost x coordinate minus the leftmost x coordinate. What's my rightmost x coordinate? What is it? Yeah, just one, because the 1 is the x, the 0 is the y. 1 minus, and then the leftmost x coordinate is? Not everyone at the same time. No, not 0. Cosine of A minus B. Close it, put a square on it. Oh, no, not a square. That's just the horizontal displacement. I'm already getting ahead of myself. I'm doing Pythagorean theorem already. And I guess you don't need the parentheses on the outside yet because I was squaring it in my head already. But there it is. That's a horizontal displacement. The vertical displacement equals the top minus bottom. What is the high y value? Way up there. Yeah, say it. Sine of A minus B minus, and then the lowest y value way down here. Well, what's the y value on the x-axis? 0. I'm doing Pythagorean theorem again, guys, because it's the same. Remember, those are the same, so I'm doing Pythagorean theorem. So, doing Pythagorean theorem. So, a squared plus b squared equals c squared. I'm just going to go ahead and call it d squared right off the bat. I'm going to go d squared equals the horizontal displacement squared. So, I'm going to write parenthesis 1 minus cosine of a minus b, close, squared, plus the vertical displacement squared, sine of a minus b minus 0, close, squared. How do we feel? Do we feel all right? I know, it's warm in here, guys. It's warm. Sorry. All right, here we go. I'm just doing algebra. I'm squaring this. What's 1 times 1? 1. 1 times cosine A minus B. Cosine A minus B. But how many of them am I going to have? So minus 2 cosine A minus B. Close it. Negative cosine A minus B times negative cosine A minus B. Yeah. Plus cosine squared of A minus B. And then the last one here, look, sine A minus B minus 0 is just sine A minus B. So when I square it, I'm just going to have plus sine squared of A minus B. We're so close, guys. We're so close. Bear with me. Are we okay so far? Okay, check this out. Look how beautiful this is. So this cosine squared A minus B plus sine squared A minus B. Look, there's another one. Like DJ Khaled said. Another one. That's just the Valentine's formula again. That's just what? 1. And what's 1 plus 1? So here's what I have now. I have d squared equals 2 minus 2 cosine a minus b. And I think we're good. All right, so catch up to here. Look at all this beautiful math we've done, guys. Don't you guys think that's awesome? All right. Look, it's going to get super cool right now. So catch up to here. Is everyone already caught up? Okay. This distance here, it's supposed to be the same triangle, but my triangles, remember I got a D in art, so my triangles suck, but they're supposed to be the same. So this D is the same as this D. Do you guys see that? So because they're the same, I can just write this expression. I can say, we can say, let's see, let's take the top one. Let's see, which one do I want to write first? I want to write this one first. We can say 2 minus 2 cosine of a minus b better equal this guy right here. 2 minus 2 cosine a cosine b minus 2 sine a sine b. And don't worry, I give you guys plenty of space. If you're running out of space, it's okay to go to the next page. That's what I'm about to do. I'm going to rewrite it here so we can reference it. So let me rewrite it. 2 minus 2 cosine of a minus b equals 2 minus 2 cosine a cosine b minus 2 sine a sine b. So there it is if you want to rewrite it really quick. We're so close, guys. Look how awesome this is. So remember what we're trying to do. Chop, what is the whole point of all this? I'm just trying to show you where cosine a minus b comes from. I notice there's my cosine a minus b right there. So what you're trying to do is get cosine a minus b by itself on the left-hand side. Do you guys see that? So to do that, I got to get rid of this 2 here first. It's 2 minus whatever. So how do I get rid of that one first? Minus 2. Whatever you do to one side, you do to the other. Bam, bam. Those are out. And now look what I have. Negative 2 cosine a minus b equals negative 2 cosine a cosine b minus 2 sine a sine b. We're so close, guys, so close. Last move. I have negative 2 times cosine a minus b. I want cosine a minus b by itself, so what do I got to do? Divide by negative 2. Whatever you do to one side, you do to all of them. Or do to everything on the right-hand side the same. So now look what I have, guys. Cosine of a minus b. Negative divided by negative is a cosine a cosine b plus sine a sine b. Is that the formula that we wanted? Is that the formula that we have right here? Yeah, there it is. If you want to put parentheses on the a and the b, you can, because that is the argument. Composite argument property for cosine a minus b. And now you know where this formula comes from. Chop, are you going to ask me to derive the formula from scratch? No. But isn't it cool that we know that where it comes from? Are you not entertained? Oh, okay. Okay. You all right, Chavez? Okay. All right, guys. What's the expectation from you guys? When you take your AP exam, you're not going to have any formula, so it's to your benefit to just know this cold. And you will. After you do it 3 or 4 times, you'll know it cold. Like, no one tells you, like, do you know your birthday? How do you know it cold? Someone probably just told you one time and you just knew it. Oh, okay. No, they're not the same? Okay. See, no one tells me my birthday. I just know it. So just do it 3 times and you'll just know it. Okay, here we go. So, Chop, what is expected? You just know how, look at this question. Express 7 cosine theta minus 23 as the linear combination of cosine and sine. What does that even mean? It means I want to see cosine and sine in my equation with a plus in the middle. Does that make sense? So, look at this. Chop, I don't know how to do that. Look, we got a formula. And we're going to get cosine and sine. So, how do we do that? Like this. I'm going to rewrite it. 7 cosine, parentheses, theta minus 23 degrees. Notice that's a degree. I don't know. When I was typing this out, I think I was like in degree mode. Next time I'll put the notes all in radians because I think we should just do everything in radians. But all right, put this in brackets. The cosine theta minus 23, put that in brackets like that. That theta is like your A. That 23 is like your B. Chop, what are you talking about, A and B? I'm talking about this. A, B. Do you guys see that? So I'm looking at the formula. So here it is. 7 brackets. And instead of writing cosine theta minus 23, I'm going to write what I have here on the right-hand side. It says cosine A cosine B plus sine A sine B. So I write cosine. Cosine of what? Theta. And then I write cosine again. Cosine of what? 23. There it is. I'm just following the formula. Put a plus. Sine theta sine 23 degrees. Close it. Do you guys see what we did? Okay. The cosine 23 degrees and the sine 23 degrees, that's a number. That's a constant. Constant and constant. So let me rewrite it, but let me rewrite it distributing the 7. So distribute the 7. So here it is. Equals. And I'm going to write the cosine 23 first because that's a constant. 7 cosine of 23 degrees. Cosine theta. Plus, you don't have to put the parentheses, but it's probably better that we do. Plus 7 sine 23 degrees, sine theta. Is anyone confused where those 7s came from? I take my calculator, and because this is a degree, what do I got to be in? Degree mode. So let's change that first. How do you change it? Click mode, and then go to degree, and push enter. This is Chavez. Hello. I do not. That's Mr. Q. Mr. Quinones. Sorry. Oh, sorry. All right. Bye-bye. All right. Here we go. I am in degree mode. All right. Here we go. Clear. And I'm just going to go 7 cosine 23. Push enter. And I'm going to write that number. 6.4435. 6.4435. 6.4435 cosine theta plus, and then 7 sine 23. I'm going to push that in my calculator. 7 sine 23. I'll push enter. 2.73511. The more digits, the better. 2.7. I already forgot it. 2.73511. 73511. 73511 sine theta. There it is. And supposedly, this and these two should be equivalent. So let's see if they are. Chav, how do you check? So I'm going to put verify or check. Verify / check. I've been, I don't know, La La Land all day today. All right, so I'm going to type that into my calculator. I'm just going to go to Y1. And I'm going to go, give me the original. What was it? 7 cosine X minus something. Minus 23. Okay. And then on this one, I'm going to type my new one. 6.4435. It's a little rounded, but that's fine. 6.4435 cosine X plus, and I already forgot what the Y one was, 2.73511. 2.73511 sine X. Let's see if that's the same. Window 0 to 360. I guess I should turn off the one of them, right? Y min, what's my amplitude? 7, so negative 10 to negative 10. Negative 10 to 10 should be enough. And X scale, let's go by 90 so it doesn't bunch it all up. Let me turn off Y2 real quick because I want to surprise you guys. It should be the same though. So here it is. Here's my graph. I guess let's go to negative 360 so we can see more. Negative 360. Negative 360. All right. Now we'll see several peaks. All right. You guys ready? I'm going to turn on Y2. And here we go. And let's see if it clears out the blue. And it does. It's the same. Cool, right? Are you not entertained? Oh.
Can you go back to the white again?
Nah, I'm not going to go back to nothing. That was a joke, miss. I promise. YouTube, that was a joke, YouTube. Do you guys see how all this is related? Like, especially to, like, look, on Monday we went from having a cosine and a sine to a single cosine. And today we went from a single cosine to having a cosine and a sine. There's more to it than this, but because I'm stuck for time, guys, I have to squeeze in the good stuff. There's more advanced stuff. If you guys want to come in, I'm gonna make it optional. I'll put it on. Maybe I'll make a video this weekend and put the stuff that we're not gonna get to, because it's all really good stuff. It's just that we're not. I'm not teaching you all of it. I'm just covering like what the essential is. You know what I mean? But if you're the type, I'm trying to give you the best education I can, guys. So if you're the type that wants to know it all, I'll make a video and I'll make the video optional if you want to see it. All right. Now that we know that, we already did that example. All right, this one, relax. All they want you to do is just convert this to a cosine and a sine, like what we just did with example one. So again, let me put the rule here. Once you do this 2 or 3 times, you'll already memorize it. Cosine of A minus B is nothing more than cosine A cosine B plus sine A sine B. See, you already have it memorized. Yeah, you do it 2 or 3 times and you'll be done. After today's activity, you'll probably already have it memorized. All right, so this 2 theta is like an A, quote unquote. This 120 degrees is like a B, and I don't know why I was in degree mode when I typed this out. I'll change it for next year so they're all in radians. Put up brackets on that, and then here we go. 7 bracket, and I'm just going to expand it using my little formula. Cosine 2 theta, that's a 2 theta, not a 20. Cosine 120 degrees plus sine 2 theta, sine 120 degrees. Close the bracket. Are we okay? I hope that we don't need a calculator for the cosine 120 and the sine 120. That's a perfect angle. We should know those. We should. So let me rewrite it. I'm distributing the 7. 7 cosine 120 degrees, because we know what that is. That's a constant. Cosine 2 theta. Plus 7 sine 120 degrees. Sine 2 theta. That's just a product, so that's all I did. I just put the cosine 120 in the front. A times B times C is the same thing as C times B times A. I can move stuff around if it's a product. Are we okay? Sorry, I'll slow down. All right, here we go. 7 times. What's cosine of 120 degrees? Chav, I don't know, Chav. It's 2 power 3, but what's the cosine of 120 degrees? The 2 power 3 is the radian of 120. Negative 1/2. Cosine 2 theta plus 7. What's sine of 120 degrees? Square root of 3 over 2. Guys, this is not going to go away. And if you're an engineer, you're going to see it for the next 4, 5, 6 years. Especially if you're an electrical engineer, because you'll be working with sinusoids all the time because of the AC current that we have. Okay, I'll stop talking. You guys at least know the difference between AC and DC, right? Right. So yeah, of course, we got to know. You guys are taking physics. The power that's provided to your house, all of that is AC current, guys. Right? Any power that's provided by a battery, look, that's a battery. That's direct current, DC. So if you're powered by a battery, that's DC current. Well, there are special cases, but you're not at that level. If it's being powered by a battery, it's DC, and if you're being powered by anything that's coming from outside the electrical pole, that's your general rule, AC. So we know at least that much, right? All right, here we go, guys. That's it. We're done. Negative. This is, well, hold on. I guess, yeah, kind of. I mean, that's what I would do, like that. And I would just verify. I would put verify. Chop, how do you verify? Let's use Desmos, I guess. No, I've been using my calculator, so I'm just going to use my calculator. I'm just going to type this in the calculator. Chop, how do you do that? Like this. I just go, what's my original? 7 cosine 2x minus 120. I'm still in degree mode, so I can just do that. And then let's see, what did I get? Alpha, y equals, enter. And what was my coefficient? 7 over 2. You don't need to do it like this. I'm just being extra. I could just type 7/2. Cosine x plus, what's the other one? 7 square root of 3 over 2? 7 square root of 3 over 2 with a sign on it. All right, here we go. I'm going to turn off y2 for now. Oh, someone honking at me. Sorry, buddy. There's my blue. Check it out. I'm going to turn on the red one. Oh, man, that's not even close. Oh, do you guys see the mistake? It's 2x. Epic fail. Second, insert 2. And yeah, it has to be the same frequency. Second, insert 2. Okay, here we go. Graph. Now we're correct. Isn't that cool? Are you guys not entertained? All right, that's it. We're done. Let me give you guys the activity. I prefer it. Well, we're not going to get it done today because we don't have that much time. But if you can get it done today, that'd be great. I'll make it. I'll put a canvas up so you can upload it. It'll be due by tomorrow. But I would like for you guys to. I didn't hook you up.
No.
Okay, so look at 1, 2, and 3. I'm assuming you probably want me to do number 1 because 2 and 3 are the same. It's just the same stuff that we did on Monday. So do you guys want me to do number 1? Okay. Don't freak out with square roots, guys. It's radicals. There's so many ways to defeat this. There's so many ways to do hacks for this. If you don't like radicals at all, guys, you can always store this to letters. You can always use your calculator. Like use technology, guys. So what do they want? Let's see. Write a linear combination of cosine and sine as a single cosine. So we're just doing this. Chop, what are you doing? We're turning that into one single cosine with a phase displacement, just like we did on Monday. So that's what we want. So what I'm going to do, to not confuse anyone, I'm going to make sure. What I'm going to do, I'm going to store this 6 plus square root of 6 plus square root of 2. I'm going to store this to B, and I'm going to store this to C. I'm just going down the alphabet. I just don't want to use the letter A and the letter D because those are already used. So here's what I do. Take your calculator, and you're just going to go square root of 6 with a square root of 4, square root of 2. Square root of 2 plus square root of 2. Well, yeah, why would it be square root of 4? That's just 2, right? Plus square root of 2. And then I just put a little arrow. You see where it says store? S-T-O? Stow? And I'm going to go alpha B. I just go down the alphabet, but A is already used for the amplitude. And so now, anytime I push B, it'll be that value. So there it is. So now I'm going to do the same thing, but instead of a plus, I'm going to put a what? Minus, and I'm going to change the letter. I'm just going down the alphabet. Instead of B, I'm going to put what? C. Chop, how do you put C? Alpha C. And now there it is. It's on C. And now look, check it out. How do I get my amplitude? I'm going to go square root of A squared. Oh, no, not A. I have it in B. B squared plus C squared. And then check it out. Wow, are you shocked that we got a nice, pretty number? No, don't be shocked. So I'm going to write A, which is the amplitude, this guy, is the square root of parentheses square root of 6 plus square root of 2, close it squared, plus square root of 6 minus square root of 2, close it squared, and we got a perfect 4. We still okay? All right, now I need the angle. Well, guys, this number is in quadrant 1. Chop, how do you know that number is in quadrant 1? Well, square root of 6 plus square root of 2, that's definitely a positive number. And then what about square root of 6 minus square root of 2? See, this is why I'm not a big fan of AI, because I think it's stopping the critical thinking. And you would think, like, maybe this is not even critical thinking, maybe it's common knowledge, but no, I mean, you still got it, like, it's arithmetic, right? Square root of 2 is a number smaller than square root of 6. See, square root of 6 is bigger. So when I subtract square root of 2 from square root of 6, it's still going to be a positive number. Do you guys see that? So it's somewhere like right here in quadrant 1. See? So it doesn't have to be perfect. So here's angle D. It's this. That's angle D. And the A you already found. That was 4. Sorry that I made this really small there. So here it is. Angle D is just arctan of this number, opposite over adjacent. So 6 square root of 6 minus square root of 2. Over square root of 6 plus square root of 2. And let's see what the calculator gives us. By the way, we're already in, what are they going to say? I already have these stored in my calculator, C and B. So opposite over adjacent, so it's a C over B. So look, arctan of alpha C over alpha B. 15. Oh, it's in degree mode. So 15. Let's put it in radians. It's not going to be as pretty, but we don't know half angles yet, so you're not going to be able to get it in terms of pi. I mean, you can, but we're not there yet. Arctan. Oh, let me go to degree mode. Radian mode, sorry. Arctan of C over B. And I guess right now it looks prettier in degree mode, but you're not going to have any exam in degrees. It's always going to be radians. 0.261799. 0.261799. I think that's pi over 12. Pi over 12. Yep. Don't worry, you'll understand half angles pretty soon, and you'll be able to get that without having to round. But there it is. So what is it? If I'm in radian mode, this equation would be y equals, what's my amplitude? 4 cosine, open parenthesis, theta minus pi over 12, or 4 cosine theta minus 0.261799. Obviously, the pi over 12 is the better answer because that's perfect. That's radian mode. If you're in degree mode, it would be y equals 4 cosine theta minus 15 degrees. Any of those three would be correct if I see it, especially if I don't tell you what mode to be in. But there it is. How do we feel, guys? Do we feel okay? All right. Take a 1 minute break if you need. Take care of 2 and 3, and then 4, 5, 6, 7, 8, 9. Everything is like what we did today. So if you have questions, let me know, and we'll call it a day.